Today we're going to cover two topics which are quite fundamental in programming in Python and also quite heavy topics, so I hope you had a good night's sleep last night. We're going to speak about Regex and NumPy. So we'll begin with Regex, which stands for regular expressions. What Regex is essentially a way to conduct more sophisticated search within text than the kind of searches that we have conducted so far. So we've seen quite a few ways to search for a substring within a string, but that's a very limited kind of a search. It only allows you to find exact matches within strings. And very often we want to make more flexible kinds of searches. We want to, for example, to find some gaps, or we want to realize some characters, and we try to find some more general pattern within text. Luckily for us, when this happens, we don't really have to write this Python program ourselves. It would be a real nightmare. Some clever people back in the 50s, they created this thing which is called regular expression, which is itself some kind of a language. So it's not a programming language. It doesn't allow you to do anything you can within a programming language, but it does have, like a language, it has a syntax and it has those rules which apply to it, by which we can specify the kind of behavior and the kind of pattern that you want to look for. And it's a language which stands outside of Python. So it's supported not only by Python, but virtually any programming language supports Regex. Within Python, it will be through the RE library that we're going to see. And it's also it's also supported by many other softwares. For example, there is the Notepad++ software, which is a very nice editor I showed you, which can also support Regex. So within Notepad++, you can write a Regex and find all the matches within a text. You can use it to find and replace. It's very nice and very flexible, and you can use it. And there is also great documentation online. So again, you can find general documentation that applies to the syntax and the language of Regex itself, irrespective of Python. And you can also find very good documentation within the usage specific to Python. So I put a link here which covers how to use Regex in Python, and it also covers quite a lot of the syntax of Regex itself. So it's a quite nice resource. So before we begin, it might actually be nice to know which of you have had some experience with Regex, or you've seen it? OK, so a few of you. OK, anyway, we're going to start learning it from scratch. So, sorry. OK, so let's see how it works. OK, I opened the Regex notebook. Can everyone see? OK, so let's begin with very basic usage, just so we get a grasp of how to use the module itself. So we import the module, RE. And then suppose that we have the text that we want to search something within it. And here is an example for a very simple Regex pattern. In this case, it doesn't really use any of the special properties of Regex. So what you get is just an exact substring match. So basically, it would be equivalent to just searching for a substring in this case. OK, so we want to find the pattern D within this sentence. So the most basic function we could use is the reFindAll function, which will find all the occurrences of the given Regex pattern within the given text. So we first give the Regex and then the text. And you can see that we find all the occurrences. In this case, it appears 3 times. So we get D. By default, it will not give us the indices, so we don't know where it occurs. We just see that this occurs in the text. And we can also use, if we want to do it, so the find all will give us a list with all the occurrences, but like we've seen in the past, sometimes it's more efficient, for example, in memory, to use a generator or an iterator instead. So we want to get just one match at a time and process it and then move to the next match. It will be more efficient to do it that way. And there is an equivalent function which is called the findIter, which is like the findAll. It will give you all the occurrences, but it will give you one after the other. So you can see I run it. I get this object, which I call matches. And when I print it, you see it's a callable iterator object. So it's some special object which you can iterate on. And for example, I can use a for loop to iterate through all the matches within the results. And then for each match, I have, it's an object which I can call some functions to get the details of the match. I can get the start and the end to see the indices within the string where this match happens. And there is the match group. For now, I will not explain why it's called a group. We'll see it later. But what this basically gives is just the match itself, so like the findAll function did. OK, so we get the start and end indices within the string. And you can see I print those indices, and I also slice the text. So you can see that the thing that I'm slicing is indeed equal to the match itself, as it should be. So you see I have one occurrences in index 0, one in index 18, and one in 34. Any questions so far? OK, there is also, if I just want one match, I don't care about all the matches, I can use instead the search function, which will just give me the first match. And if there is no match, it will give me none. And this match object is just like the match object we've seen before. So we can use the same functions. OK, so that's for finding the occurrences. There's also more functionality we can try to use. For example, there is the split function, which given a regex and a text, it will split the text according to this regex. So it's very similar to the split function that we know from Python. So because the first word is the, we get first an empty string, and then the first thing that appears after the first the in the text, and then the second and the third, and I split the text according to this pattern. There is also the sub function standing for substitute if I want to find and replace. So I can replace all the occurrences of the with this. And I get the same sentence with the word replaced. OK, so that's just the basic functionality and the different functions we can use in Python. But we've not really, we've not really dived into the special syntax and language of regex. OK, so now let's see what you can actually do with regex, which is more sophisticated than just finding exact matches of substrings. OK, sorry, before that, just a small other note. When we use the findAll or any other function for that purpose, which uses a regex, what actually happens at the background is that Python takes this regex and compiles it into some more efficient representation than it then uses to search within the text. So very much of the overall performance of Python actually goes to compiling the regex rather than invoking it on the text. So if there happens a scenario where I want to use the same regex on multiple texts, it can be more efficient to compile it just once and then to evaluate it on each of the texts instead of recompiling it every time. So for example, if I have this regex and these two sentences, so a first option is like I've shown you before. We can use just a findAll function, which will take the regex as a string and find the occurrences within the text, and you can see the matches. But there is another option which is more recommended and more efficient, and that's first to compile the regex. So we use the recompile function, giving it the regex, and then we get this pattern, which is some internal object which represents the regex in a more efficient way. And then we can use the pattern to invoke it on the text using pretty much the same syntax. So we use the same function, findAll, but this time it's not of the module. It's a bound function of this object, and we give it a text. So basically, the pattern object will have the same functions as the re module just without the first argument, which usually is the pattern. So now we don't have to specify it again. Okay, so this way is more recommended, and you can see that if I compare the performance, we will soon see that it is indeed more efficient to use the precompiled pattern rather than to compile it and evaluate it at the same time. So you can see that the first option is 700 nanoseconds, and the second is 350 nanoseconds. So it's over 2 times more efficient to use the precompiled pattern. And that's for a very simple and non-sophisticated regex. If you use a more complicated regex, the difference will be even larger. So it's really recommended if you use the same regex on multiple strings to first compile it and then to use it on each of the strings separately. Okay, and like I've said, it supports basically the same functions, just without the first argument. So I can also use the split on the precompiled pattern, and I can use the sub function, and it works the same way. Okay, so now let's get to look more closely at the syntax of regex. So for this example, let's suppose I have this DNA sequence, which you see here. And I want to find all the occurrences of an A letter followed by any letter and then followed by C. With regex, I can do it using the dot symbol, which represents any letter. So if I use the find all on A dot C, it will match anything that is A something C. And you can see that indeed what I get is ADC, AGC, AAC, AAC, everything that matches this pattern. Okay, so already we see something which is more complicated than just finding an exact substring match, which is something we couldn't do just with the regular Python functions. Now, it is important to state that matches do not overlap. So if, for example, I look for A something C within the AACC function, string, I will basically get the first occurrence of AAC, and I will not get the second option, which is ACC. So you see, both of these options are, in theory at least, valid matches to these regex. But the way regex works is that it goes greedily along the sequence. So it will first find the first match, and then it will continue from where it stops. So it doesn't make this combinatorial calculation of like finding all the options. It's not how it works. It just runs along the sequence and finds the matches. Okay, let's see more examples of the regex syntax. So something else that we can do with regex is finding repetitions. And we can do it with the curly brackets syntax. So if we put the number 3 within curly brackets after some symbol, for example, an A, it will basically match 3 occurrences of A. Okay, so we'll find A. Now it's important to state that it applies to the last symbol and reevaluates its the number that is written within the curly brackets. So making A dot dot is completely equivalent to A dot 2. And you can see that when I do A dot 2, I get things like AAT, ATT, ACA. So it doesn't really force the second letter to be the same letter. Okay, so the true means that I want any letter twice, not necessarily the same letter. Okay. And another nice thing that I can use this syntax for, I can specify any range of repetitions that I want. So if I provide 2 numbers separated by a comma, then it will mean that I want any number of t's between 1 and 3. So it will match things like ATC, ATTTC, ATTC, anything that matches this range. Questions? Okay, some more syntax. I can use the plus sign to match any positive number of repetitions. So anything between 1 to basically infinity. So AT plus C will give me anything like ATC, ATTTTC, so anything that has any number of T's and then a C. Okay, and I have the asterisk syntax, which will match any number, including 0 of repetitions. So now I can also get an AC, which doesn't have any t's within. So I can either have some number of t's or not. And there is the question mark syntax, which stands for either 0 or 1. So either there is a t or there isn't a t. So it can be either AC or ATC. Okay, now if I use the dot asterisk symbol, then it means basically I want anything. So it's any letter, any number of times, including 0. So in principle, this should match anything. But there is one letter which is exempt from this rule, which is the new line. So the \n symbol, which by default will not match a dot. So dot is anything except of a new line. So if I take a string which has different lines, and I match the dot asterisk on it, I will basically get each line as a separate match. And if I do something like a dot asterisk t, then I will get a followed by anything followed by a t. So basically, all the substrings which are a something and then t, where this something could be of any length. Now, if we do want the dot to also match new lines, we can use a flag that tells regex to do that. The way we do it is we give flags equals re.all, which specifies that we want the dot to match anything, including new lines. And now if we match something like g dot asterisk, then we'll basically get a g and then everything up until the end of the string. Yeah, and it also matches empty strings, like I said. So if I run it on an empty string, I will get the whole of the empty string as a result. And if I run it, for example, on just a new line symbol, then I will get each of the 2 lines, which is empty, as a match. Okay, more syntax. So I can also use the square brackets to specify any option of letters. For example, suppose that I want either an A or a T followed by 2 G's. I can use the square brackets to provide some set of letters. And this will be evaluated as either an A or a T, like you see here. So I get things like TGG, AGG, TGG. And I can also combine it with the other syntax we've seen of repetitions. So if I do either an A or a T, and then either a G or a C twice, then indeed I will get things like TGC, TGG, AGC, anything that is A or a T followed by 2 times G or a C. I can also combine it with the plus sign. So if I choose either an A or a T or a G any positive number of times, I will basically get all the subsequences which do not contain a C. So it will be pretty much equivalent to splitting the text by a C, because we just have 4 letters in this case. Questions? Okay, so I hope you can already see and appreciate the flexibility and the richness of this regex language, which really allows us to do quite many things using this basic language where we combine all of those simple building blocks into sophisticated search. Another syntax is the dash, which can specify a range of characters when put within square brackets. So suppose that I have this text. So now what this means is I want any letter between A to Z any positive number of times. So basically any lowercase sequence. So in this case, I just have one of these, which is the word complement. Now, you might wonder, what does the range mean? I mean, how does Python decide how to sort the letters? And the answer is that there is this thing which is called an ASCII. Maybe some of you have heard about it. It's this way to, it's the internal representation of letters in computer systems. And it basically just gives a number, an integer number, between 0 to 256 to any of the basic letters. And that is the kind of range which is used when we specify those ranges. Now, I wouldn't recommend you to make all kinds of strange ranges, but if you use straightforward ones, like between A to Z, then you can trust that within ASCII it's sorted the way you expect it to be sorted. So all the lowercase letters are a specific range within the ASCII table. And similarly, we can give the uppercase letters if we want, using this range, or between 0 to 9 will give us any digits, and here any positive number of times. And we can also combine all of these. So we can ask for any lowercase letter, or any uppercase letter, or any digit, any positive number of times, and we get all of these matches. We also have this hat symbol, which stands for not. Again, when we can put it within the square brackets. So making something like not C within square brackets will tell Regex that we want any sequence of letters which is not a C. So in this case, because we just have 4 letters, it's equivalent to the search we did before of either A or T or G any positive number of times. Okay, and you see that we really get the same result. There is also the issue of escaping. So we see that within Regex, there are all kinds of special symbols which represent something special that don't represent the symbol itself. So for example, we've seen that a dot represents any letter. It doesn't represent a dot. But suppose that we have a text which actually has a dot, and we want to match this dot. So we want to find A dot T. Now, if we just provide A dot T, then we won't necessarily get what we want. You see, we will get the A dot C because it's A something T, but we'll also get AAT because Regex, as far as it knows, it thinks we mean any letter when we say dot. But if by dot we literally mean a dot, we can use the escaping using the backslash syntax. So A backslash dot T will tell Regex that by dot we actually mean a dot. Yeah.
Isn't the R at the beginning supposed to do that?
Okay, that's different. Okay, very good question. So you asked what is the meaning of this R at the beginning. And you might have noticed that every time up until now when I define the regex, I always use this R. And that's a very good convention, which I also recommend you to use. So the R at the beginning, it does tell Python that what we put when we write the string, we mean the letters as they are in this string. So when we write a backslash, we really mean a backslash. But that's within Python. Okay, that's not within regex. Okay, once we define the string, that's within the Python syntax. Then we have the string, which in Python is a backslash dot t. And then this string is passed on to regex, which then evaluates it. And as far as regex is concerned, it doesn't even know if we define it using an R or not using an R. Okay, that's within Python. For regex, there is also only the string, which is 4 characters long. And within the language of regex, it's actually evaluated from scratch. Maybe the following example will make it clearer for you. So suppose now that I want to match a backslash. Okay, so I have something, a backslash, and then another backslash, something. So when I give regex a backslash, I literally mean a backslash. I will need to put 2 times a backslash to escape the backslash that I give. Okay, that's the way I do it within regex. So if I give it dot backslash backslash dot, it will find any it will basically find a letter backslash another letter. And you can see, indeed, the results here. By the way, it puts 2 times a backslash here because that's an escaping within the Python representation. When you see that, it's actually just that's just 1 letter. Okay, so the string that you see here, for example, is 3 letters long. It's not 4 as it may seem, because this combination of twice a backslash means just 1 backslash. That's an escaping within Python. So to make this escaping within regex, I needed to provide 2 times backslash and this R at the beginning. But if I didn't use an R at the beginning, I would actually have to use 4 backslashes, okay? Because first I have the escaping of Python itself. So when I do not use an R, if I want a backslash, I actually need to provide twice a backslash, which stands for a backslash within the string. So I would have to do backslash, backslash, and then another twice backslash. And this would actually compile within Python into a string with just 4 letters. So it would be a dot, first backslash, second backslash, and a dot. And then this would be passed into regex, which would see these 2 regex backslashes and interpret it as just 1 backslash. Okay, that's what happens when we have 2 languages, one within each other, and we have to escape both of them. So it's really an escaping nightmare. And that's the reason why we use this R at the beginning, so at least we won't have to handle with Python escaping, just with the regex escaping. Was it clear? Okay, let's see some special characters within regex. So
explain the output of the previous one?
This one. Yeah.
That's what we got.
Okay, yeah. So first of all, you need to understand that what we see here is A backslash B and B backslash C. And that's because the regex we used, we told it that we want 1 letter, any letter, followed by a backslash, followed by any letter. So indeed, we have 2 such occurrences within the text. We have the first one here, A backslash B, and the second one here, B backslash C. Okay, so when we provide 2 backslashes within the regex syntax, we actually mean that we want just 1 backslash, because the backslash is a special character that has to be escaped if we want to match it. Okay?
Why the outcome is 2 backlashes? When you
Here?
did a dot and then backslash, you just in 1 up.
Here?
Other example? No, in the
Here?
Yeah. So when we did that, we got just 1 dot, not also a
Not a backslash.
yeah.
Yeah, because that's what I said. A backslash is actually a special character within regex. So regularly, when we do a backslash, it means escaping. So if we just give 1 backslash, then what it means regex is we want the next symbol to be interpreted literally. We don't want it to have its special meaning. So normally a dot means anything. But if we give a backslash dot, it means we actually want a dot. And that's why we provide a backslash here. That's what it means in this case. If we really want a backslash, we need to give a backslash backslash. And then the first backslash is saying that the next letter will be interpreted literally. And the second letter, which is again the backslash, is the letter that we want to be interpreted literally.
So how come we got the 2 backslashes
Yeah, in
in
the
the output?
Here,
Yeah.
so like I said, it's not really 2 backslashes. It's just the way Python prints it. So let's see how it works. Okay, so let's suppose we take, let's take this one, it's simpler. Let's call it, I don't know, substrings. Okay. So if we print it, it looks like there are 2 backslashes, but you can see, for example, that the length of the first one is only 3 letters. Okay, it's not really 4 letters as it looks. It's an escaping that Python uses when it prints a backslash, because Python knows that normally a backslash has a different meaning. Okay?
So as I will continue to use this output to whatever need, then it will ignore the first backslash? Or
Yeah, and by the way, if I print it, you can see that it's really just 1 backslash. Okay, that's the difference between, by the way, the string representation. Sorry, let's do it like this. Okay, the string representation, which is just what we see, and the representation function, which you remember, it tells us how to represent it using the Python syntax. So the representation is with 2 backslashes, because that's the way you would define the string in Python. But it's actually just 1. Okay, does everyone feel good with this example? Okay, so let's move on to some special regex characters, and we'll use this song as an example. So the first special character that is often used is a \s, which stands for any white space. So a \s plus will stand for any sequence of white spaces. And I remind you that a white space is anything like a space or a tab or a new line symbol. So you can see that indeed we get all of these sequences of white spaces which appear within this string. We also have the \d, which matches any digit. So if we search for a \d within the song, we'll get all of the digits that we have. And if we use a plus afterwards, we'll get any sequence of digits. So we'll basically get all the numbers that appear within the song. There is also the \w, which stands for any what is called an alphanumeric character, which is equivalent to any lowercase letter or an uppercase letter or any digit or an underscore. So if we search for that, you can see that we get all of the words that appear within this text. And for each of these options, we also have the inverse of them, which is provided by an uppercase. So in uppercase S will stand for any non-white space character, so anything that is not a white space. So it's also an efficient way to extract all the words within a text. And a capital D will give us anything which is not a digit. And a capital W, anything that is not alphanumeric. So it's quite similar to white spaces, but also all of those special symbols like dashes and apostrophes and stuff like that. Okay, that's something I alluded to at the beginning, saying that regex is greedy. So let's see what exactly it means. So suppose that I have this DNA sequence, and I want to find all the subsequences which are A something T. If I do that, I will just get the entire string as one match, even though it could split it to smaller matches. For example, this is one match, and then maybe this is another match. But instead, it preferred to give me everything as just one long match. And the reason it did that is because the regex is what is called greedy. It tries to give me the longest result possible. So as long as it can continue, it will continue to give me the largest result that it can produce. Sometimes I prefer a non-greedy behavior, and for that we have the question mark syntax. So if we use some quantifier symbol like the asterisk, the plus, or question mark itself, or these curly brackets, and then followed by a question mark, then the second question mark is not like the first one, which means 0 or 1. It means that we want the non-greedy version of that quantifier. For example, like we saw, a dot asterisk will give me the longest string possible, except for a new line. But if we want the shortest possible, we will use the dot asterisk question mark. Sorry. And you see that now this asterisk will mean the shortest version. So we'll get each of these two options as a separate result. And similarly, we can use it for a question mark. So for example, a dot question mark means we want either 0 or 1, and we prefer to get 1, if that's possible. But if we use dots and 2 times question mark, then it means we actually prefer the 0 version. So we actually prefer AC rather than A something C. And that's what you see here. Questions?
Why do you need two question marks for this?
Okay, good question. So the first question mark here, it relates to the dot. So it means either 0 or 1 of this symbol. And the question mark refers to the first question mark. Now it means that we prefer the non-greedy version of that question mark. So instead of 0 or 1 where we have a preference for 1, it means either 0 or 1 where we have a preference for 0.
So you can, if it doesn't have 0, it would be 1.
Sorry?
If it doesn't have any 0, it doesn't have AC, it will have A.
Yeah, it would still give me a something C. Yeah, if it could. Yeah. So yeah, so if it has no option but to give it for me, for example, let's say I have ACC. In this case, it can give me either the short or the long one. And then we have a GC. Then you see that the first time it gives me the AC because it prefers the shorter version. But the second time it doesn't have a choice, so it will give me the AGC. Okay, let's see more flags. So we saw that we have this keyword argument, which is called a flag, which can get all of those flags, which change the default behavior of the regex module. For example, we saw the .all option, which tells it to match dots to anything. Another example for a useful flag is the ignore case. So by default, regex is case sensitive, meaning that it does care if it's a lower or an uppercase letter. So for example, if we look for a something t within this sequence, it will only give us the AGT option because it will only match A and T, which are uppercase. But if we want the A and T to also match a lowercase, we can give the flag ignore case, and now we also get a GT in lowercase or AAT where the T is in lowercase, and it ignores the case. If we want to give multiple flags, we can take all of the flags and use this vertical line operator within them, and then it will combine them. So for example, if we also want to ignore case and the dot to mean also new lines, we can provide the two flags together, and you see that this is indeed what happens. Okay, now we see that we can use a regex to find specific parts within a regex. So suppose that again we have this DNA sequence, and we want to find an A followed by any 3 letters followed by a T. Okay, so we want to find all the combinations of 3 letters which are surrounded by A on the one side and T on the other side. And that's indeed what we get. We get these 5-letter results, which you see here. Now, we know that the first and the last letter of each match is A and T respectively, and we might not really care about them. So we might only be interested in what's between the A and the T. And for that, we can use the parentheses syntax. If we provide parentheses, then it tells regex that what we actually want to get is just what's within the parentheses. So we want it to be surrounded by A and a T, but that's just the context. What we really care about, what we want to get, is the actual content within these 2 letters. And if we do that, you can see that we just get the 3 letters which are in between the A and the T. And we can also select multiple parts. So for example, say that we want A followed by any 3 letters, followed by a T, followed by twice C or G. Okay, then we know that the first letter should be A, and we know that the 5th letter should be T. We only care about the 3 letters in between them, and then the 2 letters which are G or C after the T. So we can surround each of them by parentheses. And then what we'll get, instead of a list of strings, we'll get a list of tuples of strings, in this case pairs, because we selected 2 parts. So each match will be comprised of 2 parts. We'll get first the 3 letters within the first parenthesis, and then the 2 letters within the second parenthesis. And that also works with the find iter function, which I showed you at the beginning. So I can iterate through that. And now I can select whichever of these, each of these is called a group. So I can select which group I want. So so the group function can have a number. So if I give it 1, it means I want the first group. And if I want the second one, I give it 2. And note, by the way, that this is a 1-based index. It's not a 0-based index like we're mostly used to in Python. And if we give 0, then it basically means we want everything, including things which are not within the parentheses. And that's also the default. So if we don't give anything, we just write group, and it's the same as 0, meaning we want everything. Sometimes it can be more neat and easier to work, especially if we have very long regexes with many parts we want to select. So instead of using parentheses, and then we need to remember what each element within the tuple stands for, we can actually give them names and then get a dictionary. So the syntax to do that is using the question mark p followed by some name within those arrows, followed by some regex. So it's quite a complicated syntax, but it's not that complicated when you understand what it does. So let's say we have the same regex as before. We have it A followed by 3 letters, followed by T. Now you see that the first letters, we still use parentheses, and then we use the question mark P. And then within those arrows, we give it the name triple, and then we provide the regex itself. And in the same way, the second group, we name it per, like you see here. Now if we use the group dict function of each match, we'll get it as a dictionary mapping the name that we gave it to the actual match. So you see that the first match will be, the triple will be AUGC, and the per will be C and G. And similarly for the 2 other matches. Another syntax is this vertical line, which stands for OR. So we could, for example, search for A something T or T something A. And that vertical line in between says that it's either what you see on the left or what you see on the right. And then we'll get either things like AAT or TCA. So either of these options. And we can also use it within parentheses and treat it as a separate block. So for example, if we want either an A or a T, or a T something A, followed by a G, we can specify it this way with the parentheses. And now you see that the results we get are some 3 letters, which match this syntax within the context of G appearing afterwards. But now we get into a trouble, because these parentheses actually have 2 functions here. First, they're used for this vertical line. So they give us some context and say that this vertical line, it doesn't apply to everything. It doesn't apply to everything on the right and everything on the left. It applies only within these parentheses. So it's to restrict the context of this vertical line. But the parentheses also have a different meaning, which is the selecting, like we saw before. So when we do that, we'll only get what's within the parentheses, and we won't get the G as part of the match. We can also use something which is called a non-capturing version of the parentheses, which again is a very strange syntax, but that's what it is. So the syntax is, within parentheses, we use question mark, and then a colon, and then a regex. And this means we want non-capturing version of parentheses. This means that these parentheses are only to restrict the context of this vertical line. They're not used to capture only this specific part. So if we do that, we will also get the G as part of the match. And you can see that we get A something TG or T something AG within the results. And this non-capturing can also be used when we use other modifiers. For example, when we use the quantifiers, like the plus sign. So if, for example, we want AT appearing any number of times, we might be tempted to give AT plus, but then the plus will only be applied to t, so we'll get A followed by any number of t's. But if we use the parentheses on the A and t, and specifically the non-capturing version of the parentheses, then the plus will apply to this sub-pattern as a whole. So it will mean AT any number of times. So we'll get AT, AT, AT any number of times we want that. Okay, is it clear?
Is the non-capturing method necessary here? If you don't use
No, here it's not necessary because that's the entire regex. No, actually, wait. I'm not sure actually because you also want any number of occurrences. I'm not even sure what would happen. No, yeah, it is necessary because you see if we give the parentheses, then the plus is not part of it and we just get one time that it appears. Yeah. Okay. So final syntax is substitution. So we've seen we can use the sub function to substitute a regex with some string. For example, we can replace all the ACG to ATG if we want. And the first regex could really be anything. So we can also, like, for example, replace all the white spaces, any sequence of white spaces with a dash. And we'll get the same song separated by a dash instead of white spaces. Now, sometimes if we use these groups, we may want to make them part of these find and replace mechanism. For example, suppose that I want to take my DNA sequence and I want to find something followed by CCG, followed by something else. And then I want to replace the context of them. So I want the thing that was on the right side to go to the left side and the thing that was on the left side to go to the right side. We can use the backslash number to refer to the groups we use. So a \1 will be the first group and \2 will be the second group. So if we replace this syntax, this regex within this pattern, then it means we want this to be replaced with whatever is in the second group, which is this one, and here the first group. So we basically reverse the order, and that's indeed what we get. And we can also use it with the named version using the \G and then the name of the group within arrows if we use the dictionary named version. And the sub function is really flexible. We can even give it a function which does the find and replace. Like you can see an example here, which gets a match and tells exactly how we want to replace it. So I won't go into this example. You can look at it later. But it's just to show you that it's really flexible and we can really make any kind of sophisticated find and replace that we want using this regex module. OK, so to end the discussion about regex, I want to show you two more real-life examples. So let's begin with the first example. If you remember when we parsed gene codes GTF format, we had these extra fields within the GTF file, and we needed to parse it into a dictionary. And we wrote this not very long, but also like a few lines of code function, which did this job for us. And I wanted to show you that we can actually do it in just one line of code using regex. So let's see how it works. So suppose that we have this string, which is the extra fields from a GTF file. And if you remember, the format is a key followed by a space, followed by a value within parentheses, followed by a semicolon and a space, and then another key value pairing, and another, and another. So let's see how we can use regex to capture these key values pairs. So we use the find all function on this string, which is the row extra fields. And what we do basically is we want anything which is alphanumeric any positive number of times, so that would be the key. Okay, we captured that, and then followed by a space. And then we want it followed by any sequence of letters within parentheses, followed by a semicolon. And please note that we use the non-greedy version here of this quantifier because we prefer the shortest thing possible. So if we didn't use this non-greedy version, it would just match everything as a one long value, which is something between parentheses. But that's not what we want. We want the shortest thing. So we want to capture it until we get to the first next parentheses. So if we do that, we use the find_all function, we'll get a tuple of matches of key and pairs. So you see that the first group is the key and the second group is the value. And we'll get a list of pairs as tuples. And then we can convert that to dictionary, and we'll get a mapping between the key and the value. So you can see that the gene ID is the value of the gene ID, and the transcript ID is the value of the transcript ID. And I hope this example illustrates how powerful this whole technique of regex is, that we can actually do this complicated parsing just with one line of code. Questions about this example?
Why is it divided to two values, I mean, one key and one value? If you only search for one thing in the find_all function.
Sorry, didn't understand.
And there's like the syntax that you wrote inside the find_all function.
Yeah.
Why is it dividing it to one set of like gene ID and the other one to the ID?
Yeah, so gene ID is just a key, okay? So it could be anything. It could be like blah, blah, blah. It doesn't matter.
Yeah.
It's like the syntax of the raw fields within the GTF, that it's some string followed by a space, followed by the value, which is within parentheses. So that's just the thing we want to capture. So you can see that my regex indeed matches this pattern that I expect. So I expect some sequence of letters, followed by a space, followed by something within parentheses. Does it make sense to you?
Yeah, but why is it not getting just a straight string of this gene ID for the time and the ID? Why is it dividing it to?
Because I use the
key and
parentheses to specify group. So I want the first thing to be one group and the second thing to be the second group, because I want the key and the value separately.
Okay.
Is it clear?
So the parentheses are the ones that doing it?
Yeah, if I didn't use parentheses, then I would just get anything as one long string, and I couldn't even convert it into a dictionary. So let's see maybe how it works. Okay, so what this gives me basically is a list of tuples, which you see here, a key, value, key, value, key, value. But if I didn't use the parentheses, then it would give me everything together. So the key and the value, and also within the quotation marks and the semicolon and everything included.
What is the role of the W?
Yeah, so W is any alphanumeric letter. So I don't want it, for example, to be with spaces as well. So it's just letters or digits or lowercase, or sorry, underscore. Yeah. Okay, so that's one real-life example. Let's see a second example. So suppose that I have this this motif. So it's something that Michal is going to explain to you in more details, what you see here. But basically what you see here is this what's called a sequence logo. So you can see that each letter within a sequence of 16 letters, how much it appears, or likely to appear within the sequence. So for example, you see that in the third position, it's very likely to see a G, and the fourth position, it's very likely to see an A, and so on and so forth. So I'm not going to get into this in details because Michal is going to explain it to you in more details. But let's see how we can use regex to match something that looks like this sequence logo. So let's say I have this DNA sequence and I want to find if I see some occurrence of this logo within the sequence. So I can, using quite crude approach, trying to write a regex, which at least to my naked eye seems to be appropriate for this logo. So the first letter, I decided that it's not informative enough, so I accept any letter. The second one, I think it's most likely to be either a C or an A, so that's what I specify here. With the next three letters, I feel quite confident that what I see as the big letters should be what I see, so I just specify the letters, and so on and so forth. So I write this regex, which matches these 13 letters long profile. And now I can just use the find all function to find the occurrence of this logo within the sequence, and you can see that indeed I find the sequence. Okay, so we're behind schedule, so I'll just say a few more words to sum up this discussion of regex. So I hope I've convinced you that regex is a very powerful way to do searches, which is a very flexible language. But it does have some important limitations that are important to know. So I wrote to you here some limitations. So the first one, which I covered already, is that matches are not overlapping. So if you want some combinatorics, finding all the combinations of a substring or a pattern within a text, then regex is probably not what we want to use. A second limitation is that it's non-recursive in nature. So if you have recursive formats like XML, JSON, stuff like that, regex won't be able to do much to help you. That's not probably the right technology to use in those cases. And the third limitation, which maybe you've already seen, is that the syntax itself is not always very clear. So it's very easy to write something which then becomes write only. So you can only write it, but later nobody can understand what you have written there because it's so complicated and so messy, and it has all of those strange letters. So when you use regex, try to pay attention to that and make sure that you're not doing things which are too complicated and might be even maybe to the extent that it's better to use other approaches. And if you do have to write regex, there are few things which you can do to make things better. Of course, you probably want to document and to write comments about what you've done. You can also write comments within the regex itself. You can see here the syntax. And you can also use the verbose flag, which tells regex to print more information about how it's searching for the regex within your string. And if you become completely clueless about some cryptic regex which you see and you have no idea how to decipher that and understand what it actually does, there are some nice tools which can help you with that. For example, I gave you here a link to some online tool which you can provide it with the regex and the text, and it will visualize the way that this regex matches the text that you have given it. So it will help you to understand which part in the regex matches to which part in the real-life example that you give it. So it's a nice way to decipher regexes and understand what they actually do. And of course, if you have a ready-to-use parser, so if you have a standard format like a FASTA file or an XML or JSON, anything, of course, just use the given parser and don't write your own parser using regex.